Let's talk about functions. Function is a rule that produces an unique output for each input. We can call the variable inside f also by the name argument, and the value what the function produces, we can also call it the image of x. In the other way around, x would be the pre-image of y. For example, fx equal to x squared is a function. We can draw its graph. We can set x squared be equal to y. The graph would be a parabola. For each value of x, we can go up to the graph and we can find the corresponding value of y. On the other hand, if we would try to make a function plus or minus square root of x, we would get its graph by taking the mirror image of the previous function, mirror image with respect to the line y equal to x. So we would get this kind of graph for our operation, which is not a function, and why it's not a function. For each value of positive x's, we would have two values of y here. So we don't know what the value of the function is. Is it this one or is it this one? We don't know. So to make this expression a function, we need to choose. Maybe we choose the plus sign. We need to delete the other half of the graph. Plus square root of x is a function. We can also represent functions in other kinds of diagrams. For example, we can have here numbers -2, -1, 0, 1 and 2. And here are some other numbers. And we can consider the function x squared. X squared sends 0 to 0. Both 1 and -1 to 1. And both -2 and 2 to 4. Now, some of these expressions here have some names. The set where the function is defined is called a domain, and the set of values what the function might get is called a codomain. From the codomain we can see the points which were actually the values of the function. This set is called the image set, and if we would give these sets some names, we denote the domain by A and the codomain by B, then the image set we could tell that it is the image of the set A. Now this function does not have an inverse function. It's because f of minus 2 is 4 and f of 2 is also 4. So if we would have an inverse function and we would try to apply it to 4, we would have many options. So this inverse operation, it's not a function. Inverse function does not exist. If we have a more simple function, the inverse function might exist. If we, for example, restrict the function to be from non-negative numbers to non-negative numbers, then we would get that in the previous example, now we just choose some positive numbers here. And we would get that if the function is x to power 2, 0 would go to 0, 1 to 1, 2 would go to 4, and so on. We would have here 9 and 16 also, which would be the images of 3 and 4. For this function we would have the inverse function, because now we don't have any negative numbers. In the domain, we took the domain to be smaller. So now we don't have any problem. We can take all the arrows and we can switch them the other way around. Let's see. So now in the inverse function, we would have that 9 is mapped to 3, 16 is mapped to 4, 0 is mapped to 0, and 1 is mapped to 1. Still we need to find some values for 2 and 3. Well, in the set of real numbers we have the square root of 2. 2 goes there, and we have the square root of 3. Square root of 3 is the image of 3 in the inverse function. Let's see how we can find the inverse function if we are given a formula. For example, our function might be a function like this, and we would want to find the inverse function. Let's set this value to be equal to y. And our goal is to solve x. We can multiply by the denominator. Open the parentheses in the right hand side. Shift all the terms with x to the left hand side. Take x as a common factor. And now if 1 minus 3y is not 0, we can divide by that and we would get that x is a number like this. So we would get that this expression here would be the formula for the inverse function. Now here the variable is y, so we have y everywhere. If we want to write the inverse function by using the variable x, we can change the variable. X minus 2 divided by 1 minus 3y. Now we have some facts from here. If we want to write the function in a more smart way, we see that the original function is not defined if the numerator is 0. That would mean x is equal to minus 1 over 3. So the function is actually from the set of real numbers minus that number. To the set, and we see that the inverse function is not defined if this would be 0, that means if y would be equal to 1/3. So f is a function like this, and the formula of f is as we wrote in the above. So for this function we found the domain and we found the image set. If we are given the task to find some domain and image set for a function like this, we have a more easy option. We can graph the function. This function whose inverse function was this one, x cannot be here 1/3 and x cannot be here minus 1/3. We can mark the problem points here. Here we have 1 minus this one, and here we have the other one. Let's see. Yeah, so if we would draw the graph of this function by using the computer, we would get something like this. We can read the domain of the function from the x-axis, and in this case the function would be defined for all values of x except for minus 1/3. And we could read the y values from the y-axis. The graph is going here side by side with the y-axis, and in the spot of 1 over 3, the graph does not go there. So we could see that the image of f is the real numbers minus this number. So for function f, the domain is real numbers, but take out minus 1 over 3, and the image is real numbers, but take out 1 over 3. Let's see the other functions what we were considering. We can see for the square root function that the domain consists of those values that x is at least 0, and the image consists of those values that the function is at least 0. These were some concepts related to functions.